Hello everyone, this is Jyoti, and today I'm going to show you how to get the deflection for a particular point in STAAD in Excel through OpenStaad. Generally what we do, if I want to find out the deflection for this and this point, suppose this is 281 and this is 1524. What we used to do, this is range, we give the range for nodes 281, and what is the second one? I forgot. Okay, for 281 consider. And for load cases, suppose 61, 62, 63, and suppose 65. This is the lengthy procedure. And you have seen I have forgot the second node number. This is 1524. I had to put it, but I forgot it. So what we can do? Straight away we can program it using OpenStaad statements, which has been provided by STAAD itself. So we can make a programming in VB or macro to link STAAD Pro with our Excel sheet. So start. We will do the programming now. Suppose I want to find out the deflection of a node for these load cases, and I want program to print the nodes, load cases, and three displacements in translational direction because we are not interested in rotational directions. So let's start then. Insert a button. I will rename it as get deflections. Okay, start programming. I have to define some variables as usual, as we did in last tutorial. As object, this is the object I'm defining open obj OpenStaad, which we are going to use to link our programming to OpenStaad. Then number of load cases, number of LCs as integer. Then one array to store the list of load cases. Then what we are going to do, whatever we select here, suppose we have selected these 6 nodes. By clicking this button, we will get all 6 nodes populated over here. So no need to find out, no need to see what are the node numbers over here like this, and like that. Or by switching on the mode to show the nodes, it will be very clumsy to see the screen. So LC, then selected node numbers. As integer. Then array for selected nodes, list of selected nodes. As long. Then array for displacement array. Sorry. With 6 components in it, that will be of double category. As so from where can I get the value of this number of load cases? So number of LCs is equal to, says 2 I think. Let's check. Yes, it is 2. Then we allocate the index for this array. So reading LC with number of LCs. Then we will set the object. Is equal to get object, sorry, comma, inverted comma, STAAD Pro dot STAAD inverted comma close. Now I want to get the number of selected nodes, and this line connects our programming with STAAD. Now selected node numbers is equal to obj OpenStaad dot geometry dot get selected nodes and store it in selected nodes array. So cell node numbers is equal to OpenStaad obj OpenStaad dot geometry dot get number of selected nodes. Sorry, I'm sorry. So these are the selected node numbers is equal to obj OpenStaad dot geometry dot get number of selected nodes. So number of selected nodes will be stored in this variable. Now we will reallocate the index to this array. So cell nodes selected node numbers -1. -1 means in OpenStaad every array start with 0 index. Now I will find out which nodes I have selected. OpenStaad dot geometry dot get selected nodes and save it in cell nodes. Okay, obj OpenStaad dot geometry dot get selected nodes and cell nodes. Now what I want to do, I want to write selected nodes in this column and load cases in this column. So I will write loop for it for selected numbers. For j is equal to 1 to number of LCs. Where I want to type, once again I will check. 4 plus I, 6 and 7. Cells 4 plus I, 4 plus J, sorry, plus I minus 1 into number of LCs and 6 is equal to cell nodes I minus 1. I told you why this is I minus 1, because the array starts with 0 index. That is the reason. Then for load cases, everything will be same, but here the column number will be 7 and here LC J. Here we can't put j minus 1 because this variable has been defined by us only. It is not from OpenStaad. So let's check. Are we going on right track or not? Next. Next. Okay. Let's have a look. Debug. STAAD Pro. Spelling mistake. We have to be very careful for the syntax. Again, cell node numbers, obj OpenStaad.geometry get number of selected nodes. Again, what's the problem? Cell node numbers is equal to obj OpenStaad.geometry.get number of selected nodes. I'm sorry, I'm not a good programmer. Yeah, but LC is wrong because I have not linked this cell in the programming. So let's see. What is LCJ? So I have to define it first. So here LCJ is equal to cells. What are these cells? 3 plus I. 3 plus, sorry, J. J is the variable for number of load cases. And 2, I think. Second column, let's check. Yes. Can we run this? Yes. For these are the selected nodes. 281, 1453, 1524, 1529. You want to check? See. 281, 1554, 1524, 1529, 1549. These are 6 nodes and 5 load combinations or load cases. So is equal to 6 into 6 number is equal to 6 into 5 load cases. So 30. Yes, count 30. Okay. So next step, we have to print the deflections, displacement of these numbers with respect to these load cases. 61, 63, 65. Okay. So we add one more command line to get the displacements. obj OpenStaad dot output dot get node displacements for selected node nodes I minus 1 for LCJ and store it in displacement array. That's it. Okay, what is the problem? I have forgot to give a comma over here. Let's check once again this command line, which we are going to extract the displacement from STAAD. So obj OpenStaad dot output dot get node displacements cell nodes I minus 1. Why I minus 1? I minus 1, I'm telling you again, because whatever the arrays formed by OpenStaad, those arrays starts from 0 index. 0 means 1. LCJ displacement array. So I will print it, and for that I have to write a loop. A is equal to 1, 2, 3. Why 3? Because I am interested in first 3 displacements. That is in translational displacements. I'm not interested in rotational displacements. So cells 4 plus j plus I minus 1 into number of LCs, comma 7 plus k is equal to displacement array q minus 1 into 1000, because OpenStaad gives me the displacement in meters, so I want it in mm. Next, k. Let's check. Yes, I got the displacement. So for which node we have found out the displacement? 281 dash 1453 dash 1524 dash 1529 dash 1544 and 1549 for these 6 nodes. So I will cross check with it. Range, apply. Okay, let's see. Okay, oh, I have to define the loads also. Every time I have to do it. I don't know what is the shortcut for it. That's why I prepared this program. And I am very lazy to do the repetitive work. So I want it in one click only. See, you can see my speed and make it out how lazy I am. Right. Okay. So check whether our displacements are correct or not. For 21, 281 it is for 1061 it is minus 1.084, 7.24, this 40, then it is 5.5 minus 3.2, 43. For second node 1453 minus 1.172, 6.525, and here 40 Good, correct. So got the tips? So you know how to work smart now, correct? Thanks for watching this video. Thank you very much.